Hello, welcome back. Hearty welcome to you. We are going through some examples as part of sequences and series. Arithmetic progression sum of or sum to n terms. We have a problem. Let's try to solve it together. So, find the sum to n terms of an arithmetic series or arithmetic progression whose kth term is 5k plus 1. So what we have to find out? We have to find out S of n. We have to find out S of n. What we know? We know S of, we know that kth term, right? Kth term means what is that? A of k is equal to 5k plus 1. Okay, right. We have to find out Sn. What is the formula for Sn? Sn formula is n by 2 into 2a plus n minus 1 into d, or I can also say a plus l, or l equal to an, nth term. Okay, if I know first term and nth term, then I can take average of them, multiply with the number of terms, I will get sum of n terms. Now let us check what is your a. A1 is nothing but equal to a equal to a1 equal to 5 into 1 plus 1, that's equal to 6. So we know a equal to 6. Now what is the last term here when you want to find out nth term, right? So I'll directly go ahead and say L equal to an equal to 5 into n plus 1, that's nothing but equal to 5n plus 1. Now you want to find out the value of S of n. So what we will write? We will write directly S of n equal to n by 2 into a, that is 6, plus l, that is 5n plus 1, that's nothing but equal to n by 2 into 5n plus 7. That's the sum of n terms. What we have done? We have been given ak, so based on that we have found out what is first term and what is nth term. We know sum to n terms is nothing but n by 2 into a plus l, but l is also equal to an. So we substitute in the whatever the equation given to us, ak equal to 5k plus 1. I get the value of a and substitute that in that. Let's do the next problem. Here we go. The problem we have is, if the sum to ends of an arithmetic progression is Pn plus Qn square, where P and Q are constants, find the common difference. So what has been given, what we have to find out? We have been told that S of n is nothing but Pn plus Qn square. What we have to find out? We have to find out d. Now how to find out d? We know the Sn, right? What we will do now, we'll try to find out S1, S2, S3 by substituting in this formula. Let us find out what is the sum of one terms. Let us say that we'll write it as A1, A2, A3. Okay, right. These are the, let us say these are the terms which are part of this series. S1 equal to P into 1 plus Q into 1 square, that's equal to P plus Q. What is S of 2? S of 2 equal to P into 2 plus Q into 2 square, that's equal to 2P plus 4Q. Now let us do one thing. We know that this is the series, right? This is our series. What we will do? We'll write down in terms S1 is nothing but equal to sum of one term only, that is nothing but A1 equal to P plus Q. Now next one, S of 2. S of 2 means what's the meaning of that? First two terms I should add. So that is equal to A1 plus A2. That gives me 2P plus 4q equal to a1 plus a2. You know what is a1, right? We just know that. P plus q plus a2. That gives me, let us see what we will get from that. We'll get a2 equal to 2p plus 4q minus p minus q. That is nothing but equal to p plus 3q. Now what is common difference, by the way? Common difference d is nothing but equal to a2 minus a1. So what we have done? We have applied whatever is given to us formula. By that we know what is sum of one term, sum of two terms. Now we know that sum of one terms is the first term. Sum of two terms is first term plus second term. So if I want to find out the second term, I should, you remember that in the last problem we have done that a2 is nothing but equal to s2 minus s1. It's not only for a2, whenever you want to find out, suppose let us say you want to find out a of 10, that's nothing but equal to s of 10 minus s of 9. Now d is nothing but a2 minus a1. What's the value of a2? P plus 3q minus a1. a1 is nothing but minus p minus q, minus of p plus q. P cancels out. 3q minus q is 2q. So your answer is 2q. The common difference is nothing but 2q. What we have done? We have applied Sn, S1, S2 we have found. We know S1 is A1, S2 is A1 plus A2. Based on that we found what is A2. Now once we know A2, the common difference is nothing but A2 minus A1. So let's do one more problem. This is an interesting problem. Let's go through that and try to understand and solve that. The sums of n terms of two arithmetic progressions are in the ratio 5n plus 4 is to 9n plus 6. 5n plus 4 is to 9n plus 6. Find the ratio of their 18th terms. So what we know? We know that sums are in the ratio 5n plus 4 by 9n plus 6. So we know the formula for how to find out the sum of a arithmetic progression n terms, right? What is that formula? We use s of n equal to n by 2 into 2a plus n minus 1 into d. This is the formula for s of n. Now we know they are in the ratio. So let us say there are two arithmetic progressions. We will take two arithmetic progressions. Let us say in the first, let us say a1, a2, okay, right, or okay, in the first one we call the first term as a1. Here let us say the first term is, let us say a11, okay, fine. Let us say instead of a11 we will say a1 dash, maybe that will be better. Okay, right. So we will say a1 dash, and the common difference here is d1, and the common difference here is d1 dash. Okay, now how the ratios of sums to n terms looks like? Let us apply the formula. We know sums of n terms of two arithmetic progressions. So for the first one, the formula will be n by 2 into 2a1 plus n minus 1 into d1. This is the first arithmetic progression, sum to n terms. Now this I have to divide by the second one. This is nothing but equal to n by 2 into 2a1 dash plus n minus 1 into d1 dash. Now this is given to us equal to nothing but 5n plus 5n plus 4 divided by 9n plus 6. Now I can cancel n by 2, n by 2. I will just leave it there as it is. Now what I have to find out? I have to find the ratio of their 18th terms. Let us find out what is the ratio of 18th terms. Ratio of 18th terms. That is what I have to find out. Right? How it looks like. I know that 18th term is nothing but a1 plus 17d divided by a1 dash plus 17d dash. This is what I have to find out. Now, if I compare this with whatever I have on the left hand side here, you see that 2a1 I have here, here I have only a1. So what I will do, I will multiply this with numerator denominator by 2, so that it becomes 2a1 plus 34d by 2a1 dash plus 34d dash. Now can I write this 2a1 plus 34d in the format of whatever I got earlier, so that I can apply this particular formula? So what I will do, I will take one more step and say that is nothing but equal to 2a1 plus 35 minus 1 into d by 2a1 dash plus 35 minus 1 into d dash. Now you can see very clearly, if I compare 2a1, n minus 1, 35 minus 1, that means my n is nothing but equal to 35. So I can directly go ahead with this formula where n equal to 35. If this is nothing but whatever I got, the ratio of 18th terms is nothing but suiting to this particular whatever the equation we got earlier where n equal to 35. So if I substitute n equal to 35, 2a1 plus 35 minus 1 into d1 by 2 a1 dash plus n is 35 now. So this also should become 35. That will be 5 into 35 plus 4 divided by 9 into 35 plus 6. Now 5 35s are 175 plus 4 is 179. 9 35s are 315 plus 6 is 321. So your answer is 179 by 321. So what we have to understand in this type of problems is, once we get this equation, now in the second when we go to actually find out the 18th terms, we see that this is almost there in the same format as whatever the equation I got earlier. So we made it equal to that particular equation, so that correlate it, so that you can find out the value by directly substituting the value of n. So those are some simple examples. We will solve some more as part of sequences and series arithmetic progression. Thanks for visiting. Bye for now. Thank you.